Hi, this is my project Milestone 1 video, and in this video I am going to explain which algos I have chosen, and I will be executing those algorithm and report their time for 5 runs. Now my first algorithm is face detection algorithm, which I have used is hard cascade face algorithm. Face detection. Now first of all we have to know what is face detection. Face detection is a computer vision technology that helps to locate and visualize human faces to digital image. This technique is specific use case of object detection technology that deals with detecting instances of semantic object of a certain class, such as human, buildings, or cars, in digital images and videos. With the advent of technology, face detection has gained a lot of importance, especially in field like photography, security, and marketing. This is my face detection algorithm code, which is written in Python, and here is CV2 package, which is OpenCV and imported as CV2. Here I have loaded the cascade classifier XML file, which is presented this, and first I have taken the input of the image, which is this image as input, and then convert this input image as grayscale, because this is the requirement of the hard cascade classifier. First it will convert the image into grayscale and then detect the face, and then draw a rectangle around the face. Here is the loop, and rectangle code is here, and at the end CV2 OpenCV package and .im show function, and here is the image which will be output. Now run this code. Open terminal, and here type python 3 and the name of this file r.py. Now when I hit enter, it will draw a face, a rectangle around the face. Here was the input image, and this is output image on the right side. So now I have to run perf. Now check execution time using perf command. Perf stat dot slash and r.py and file name. This is the execution time, which is 0.0018 seconds. 1.27 task clock, and 0.677 CPU utilized. This task clock shows that how many CPUs were used during the execution, and the context switches in this case is 0, where context switch is the process of storing the state of process or thread so that it can be restored and resume execution at a later point. This allows multiple processes to share a single CPU and is an essential feature of multitasking operating system. As we know that this is a serial program, so context switches in this case will be 0, and CPU migrations are also 0. CPU migration is when a thread, usually after a context switch, gets scheduled on a different CPU than it was scheduled before. So this will be a CPU migration. This is also 0. And page faults, which are 71. A page fault is a type of exception raised by computer hardware when running program accesses a memory page that is not currently mapped by the memory management unit into the virtual address space of process. While cycles are 3.7 million at the speed of 2.95 gigahertz. With every tick of the clock, the CPU fetches and execute one instruction. The clock speed is measured in cycles per second, and 1 cycle per second is known as 1 hertz. This means a CPU with a clock speed of 2 GHz can carry out 2000 million cycles per second, and here is our 2.95 GHz. Instructions are 1.39 millions. So instruction is a single operation of a process defined by the processor instruction set, and branches which are 291,000 branches. Branch is an instruction in a computer program that can cause a computer to begin executing a different instruction sequence and thus deviate from its default behavior of executing instruction in order. And branch misses, which are 12,000 and 4% of all branches. It means we got 4% of branch misses. A branch predictor is a digital circuit that tries to guess which way a branch will go before this is known definitively. The purpose of the branch predictor is to improve the flow in the instruction pipeline. If then else structured statements. So that was our first run. Now execute it for the second time using perf stat and /file name and extension of the file name. Press enter, and here is a changes in the execution time, 0.001 for the first, and this time 0.0009 seconds. Now execute it for the third time. This is there is again change in execution time, which is 0.0032, and now run it for the fourth time. Again execution time is changed, 0.0015, and run it for the fifth time, and we got 0.00306 seconds. Here page faults was 72, and here are 73, and cycles were 4.2 million, and here are 3.16 millions, and instructions are 1.4 million, and here are also 1.414. Branches were 294k, and here are 292k, and branch misses were 4%, and here are 3.95%. This was the execution of hard cascade face detection algorithm. And my second algorithm, which is corner detection with high risk corner detection method with using OpenCV. Harris corner detection algorithm was developed to identify the internal corner of an image. The corner of an image are basically identified as the regions in which there are variations in large intensity of the gradient in all possible dimension and direction. Corner extracted can be a part of the image feature, which can be matched with features of other images and can be used to extract accurate information. Harris corner detection is a method to extract the corner from the input image and extract the feature from the input image. Now we are going to execute the corner detection algorithm. And the corner detection algorithm, which is implemented here is a high-risk corner detection algorithm. Here first the file name is corner.jpg, which is taken as input here. Image read file name, this is passing here file corner.jpg, which is this image. This is input image, and first it will be converted into grayscale images, and this gray is passed, and again value is changed, and here corner hard is, and here are some parameters of the corner detection, and 2 3 these are the dots which will be located here and here to present corner in the image. And here is destination dilated, and the threshold of an optimal images, and again the last function which is cv2 OpenCV package, and I am show dst image, which presents the output. Now check it by executing python 3, and name of the file which is corner.py, and here as we can see that the red dots appear on the corners of the image, which represents the corner. And here was on right side there is a input image, and this is the on right side, this is on left side this is output image. So now I will be using Perf to analyze the performance and execution time for the corner detection algorithm. Perf stat and dot slash and corner dot py. Now here is the perf command. Perf stats are here, and the execution time is 0.02714127 seconds. First it's a task clock, which is almost 0.75 CPU utilized, and 16 time context switches during the execution, and CPU migrations are 0, page faults are 9 to 8, cycles are 55 millions, and instructions are 29.7 millions, and branches are 6 millions. Branch misses are almost 4.37% of all branches are missed. Here is the execution time 0.027. Now let's run it again and check the execution time, the difference in the execution time. Here as on the first execution the time was 0.027, and in second execution 0.023. There is a slight difference in the execution time, and the task clock are now 0.94 CPUs are utilized, and context switch in this case are 3, and one time CPU is migrated, and page faults are 9 to 9, and cycles are 53 millions, and here are instructions and branches, and this time 4.12% of all branches are missed. Run it again and check the execution time for the third time. Now this time the execution time is 0.019 seconds, which is again difference from the first and second run, and task clock is 18, and CPU utilized are 0.957, and 2 time context switches, and CPU migration is 0 this time, and page faults occur during the execution are 925, and 45 million cycles at the speed of 2.49 gigahertz, and instructions are 0.65 instructions per cycle, and branches are 6 millions, and branch misses this time are 4.09% branch misses. Now again run it for the fourth time, and again the CPU execution time is 0.008 86, which is a difference from the first third execution, and this time context switch is 1, and CPU migrations are 0, page faults 927, and cycle rate is 3.21 gigahertz, and instructions are 1.12 instructions per cycle. And here is the branches, and branch misses are 4% of all branches. Now again run it for the 5 and last time. As we have continuously noted the execution time difference in execution time. Now this is this time 0.014 seconds, and the task clock is 0.923 CPUs utilized, and task clock is 13.23. Context switches in this case is 1, and CPU migrated 0 times. Page faults are 928, while cycles are 3.028 gigahertz speed, and instructions are 29 million and at the rate of 0.74 instruction per cycle, and branches are 6 million and branch misses are 4.12%. That's it. That was the milestone 1 requirement. As we can see that I have executed it for 5 times. That's it. Thank you.